All right, the GRE Tunnel config. Before to do or to deal with the configuration, let me give you an overview about our lab. This lab will be used as a simple idea, and maybe later on we will do a lot of steps. I need to show you here. I've got three switch, layer 3, and one or switch 1 here. Let me draw something here. I've got here switch 1 and switch 2 and switch 3. Switch 1, this network will be used 10.111 in this side and 10.112 in this side. And this network here will be used 20.111 in this side and 20.112 in this side. And after that, I will make I already configured the OSPF routing between those and those as well. So that means I have a full connectivity in this network under Area 0 OSPF domain. So the first idea from the GRE tunnel, if you need the GRE tunnel, you have to make the connectivity. You have to have the infrastructure here. The connectivity between the points you're looking for. So if you don't have a pingable from this point to this point, okay, you cannot do the GRE tunnel. We cannot create the GRE tunnel. So the first thing, the connectivity. So I already did the OSPF routing protocol here. You see, I put the configuration here in that guy. And I put that configuration in that guy, and put that configuration in that guy. And after that, I will show you how to configure the tunnel interface. Before to start the tunnel configuration as well, just keep in your mind switch number 1. They have a loopback 1.1.1.1/24. Actually, I deal all with the /24, but in real environment. Of course, this one is /30 to 55.255.255.252. That guy is same. And loopback in switch 3, I put it 3.3.3.3. So why we need a loopback? Why I mention about loopback? Because the tunnel, or the old style to configure GRE tunnel, they put it, this is the source for the tunnel and this is the destination for the tunnel. If you are here, you say, okay, this is my source and this is my destination, and will be works, no problem. But the tunnel here is related to the physical interface. If the physical interface went down, mean all the tunnels will be down. And by the way, we can create more than one tunnel in one interface or in one physical connectivity. That's why in the last time, or the old style to configure the GRE, they use a physical interface. In our configuration, we never use the physical interface. It's not only my configuration. In real environment, nobody use physical interface. Everybody use the loopback interface. So this is a very important thing. We need to put it in your mind. Loopback interface will be the source, and loopback interface as well will be the destination. Okay, I will start from the service provider or whatever, any switch, doesn't matter. I will go to this switch. Switch 1 here. I will show you the configuration here and set this switch very quick. ENA show IP interface brief EX1. Don't give me exception the unassigned IP address. So you can see here I have one interface, that guy G0/0. I give him IP address 10.111, and I have a loopback. The loopback will be my tunnel source. Okay. All right. Let's go to the another switch, which is switch 2, switch 3, which is the point B in our scenario here. And I will go to this guy, show IP interface brief. I try to typing a little bit quiet or a little bit soft because My typing sometimes is very tough. So I say brave and included or EX exception UN and assign IP address. As you can see here, 20.1.1, which is this interface, and 333 loopback. The loopback again will be the source for the tunnel, and the destination for another tunnel. We will see that in the tunnel configuration. Let me check the routing here. Did I do the routing here? Yeah, in the router 3 show run section OSPF to see the OSPF configuration here. I already did the OSPF for switch 3. They do OSPF with the service provider. Let's see the result here. You can see the IP address here. This router ID is a 32-bit. You can put it wherever, any router ID, which is the service provider, ENA. Of course, the service provider, they have a routing here. You can see the router 1 here. Yeah, the router 1, the result is coming here. From router 1, I can ping show IP route included capital O, which is to see the only OSPF. You can see I have OSPF routing, mean router 1 can reach to the network, or switch 1 can reach to this network 20, and at the same time switch 3 show IP route included O. So as you can see, they have as well accessible to the network switch 1, so I can do ping to the 10.111. Another side I have reply, and as well from here I can do ping to 20.11. I have reply as well. This is a very important thing, which is mean I have the connectivity between those points through the service provider. Cool. Now I will start to do the tunnel. Okay, so let me show you the configuration for the tunnel in the old way, the old style, with the physical interfaces. Here I will say config t interface tunnel. I will call it, let's say 100. Okay, IP address for that tunnel will be 100.100.100, or it is between switch 1 and switch 3. I will go for 103.111.255.255.255.0. Okay, so you can see the tunnel say down. The tunnel 100 is changed states to down. Okay, so because there is no source and no destination, so I will say here tunnel source. My source will be remember I'm in the switch 1. My source will be gigabyte 0/0. Okay, this is my source. This one my source 10.111. You can put it even 10.111, doesn't matter here. Okay, my tunnel destination here, okay, my tunnel destination here will be 20.111 in another side. Remember, very important thing, when you put it the source and destination, this tunnel look like it's point to point. And it is point to point actually. Later on we will see when you do in DMVPN, when you use the GRE tunnel with the multi-point mode, will be point to multi-point. The wonderful thing here, it is I receive the tunnel is up. So it means the tunnel, if the destination available will be up. So what I mean, if that tunnel destination is not accessible, the tunnel is not went up. Okay, let's go to configure another part in the switch 3. I guess the switch 3 right there. Yes, config t interface tunnel 100 or whatever, any number. This is local significant, so I just say IP address. You see the tunnel went down because the fundamental or the parameter for that tunnel is not there. So 103.111, the IP address 103.11255.255.255.0. That was wrong IP. I have to say no, because it's the same IP as the another side. So I just say 3, that guy. Then I say enter here, tunnel source as well, gigabyte 0/0, of course, because I am here in that switch, so of course my tunnel is 0/0. Then my tunnel destination will be 10.111 in another side. Once this one accessible from me, routing from me, or routed from my side, means I can see my tunnel is went up. Perfect. So can I ping now to the new network, which is 13.111 in another side? You can see the tunnel is work right now. The tunnel is work here. So again, this style here for the tunnel, let me show you the tunnel itself. Show interface tunnel 100. So the tunnel here is up. As you can see here, is up, and you can see, very important, the encapsulation is tunnel, and the tunnel here source, this is IP, yes, in the switch 3, this is the IP physical interface, as you can see here, and the destination is in this IP. Right now my tunnel, actually it is relayed to the physical interface. It's not really the recommended configure in most of the companies. Most of the companies should be use the loopback interface as a source and the destination to make this tunnel is totally logical interface participate on it. So how to do that, this is we will see in the next or in the following class.